Hello, welcome back to Cracking the Cryptic and a puzzle called Border Dispute by Staxis today, where I don't think we're talking about geopolitical borders, we're talking about Sudoku grid borders, but that's fine. We'll look at that in a moment. In fact, that's much better. And I'll go through the rules. I do want to remind you that on Patreon, we've got the fantastic Bug Friend Sudoku Hunt by Sandra and Nala, where you can help Nala find loads of bugs. She's a dog. And Sandra's her owner and has to try and look after her. And you can help Nala through the fog, finding the bugs. There's not just Sudoku, there's Hayawaki and Nurikabi there as well. So give it a try, it's fascinating and it's a good challenge, although lots of people have got it right, so very well done to them. And absolute pleasure to see the reviews. We've also, of course, on Patreon got gridogram and connections and crossword videos, so do check that out. They go along with the masterclasses on Friday. Of course, today there was a masterclass by Simon on the Times crossword, and there's my monthly club special on Patreon as well. I mean, anyway, loads going on. Blueprints streaming on Monday night. We'll definitely be there, and we'll be looking forward to that. We've got Minute Cryptic and Wordle in a Minute every day, and we've got our apps, including the latest release, Blobs' Eclectic Worm, 12 puzzles of 6x6 connected Sudokus. Fantastic value, as all of our, well, Patreon is as well, but all of our apps and worms really are. The amount of logic for your dollar is amazing on those. Do check it out. We've got Arrow Sudoku and Domino Sudoku as apps amongst our suite of apps as well. Please have a look. Now, the first link under the video, however, in the description field is to this puzzle, Border Dispute by Staxis, so you could play it there if you fancy a go. I'm going to explain the rules, and I think they're a very short set. Normal Sudoku rules apply, 1 to 9 in every row, column, and 3x3 box. Well, that's normal enough. Each domino crossing a region border, so a domino is a pair of cells that share a border. Each domino crossing a region border must contain a unique pair of digits. For example, if a 1 and a 2 touch over a region border, that would be such a domino. And then 1 and 2 cannot touch over a region border anywhere else in that case. And then digits in cells on a white dot are consecutive. Digits along an arrow sum up to the number in the circle. And that's it. That's all we get for this grid. Apparently it solves uniquely. That is a conundrum that often occurs, but let's see if we can get to a solution of this one. I'm going to start the puzzle now. Let's get cracking. So the arrow is good. This arrow is good because those 3 digits have a minimum total, which is 6. They have to be at least a 1, 2, 3. These two are in the same row, so they have to be different. Their minima are 1 and 2, giving a minimum total of 9. If you add 6 and 9, you get the maximum total for a single cell, and that digit must now be a 9. So we've done something. This arrow is shorter. Oh, but hang on, these 3 cells see that digit. So now the minimum for these 3 cells is one of those numbers, 1 or 2, and the next 2 minima are 3 and 4, and that is going to take our total to 8 for those cells. And then we know plus 1, the remaining minimum, equals 9, the maximum for the circle. Right, we have now found 9 in 2 circles in this puzzle, and I can now guarantee you that 9 is not going to appear in any more of the circles, and that is because obviously these 1 cell arrows are showing us 2 identical digits. I was going to say across a border. That's not across a border in terms of the rules. They are across a box border, but they're not providing a domino across the border. Anyway, that 1 sees this cell. Oh, and there's a 1 in one of these cells that sees that cell and makes it a 2. This is a 1, that's not. I'm beginning to feel instinctively that we are absolutely running out of information now. I mean, this digit on this arrow and dot here, it can't be 1, 2, 3, 4 or 9 because its appearance on this dot is going to use up its 2 appearances in columns 6 and 7. So it couldn't appear again in those columns. And we know that 1, 3, 4, 2 and 9 do. So that yellow is 5, 6, 7 or 8. I want to say the same about these, but I don't think I can rule out 4 from them either. I might not be able to rule out, well, okay, this one actually does see all of those 3 digits in one box or the other. But this one doesn't necessarily see that digit. Okay, we're going to have to do something clever with borders and these digits that look across borders. So all we've had so far is a 1-9 pair. That means this digit can't be 9 because it's looking at the 1. 9 is a bit limited in this column actually. No, I mean not very. But it can't be there, there, here, here, or now here, or here. So it's limited to 3 spots. This digit can't be a 1. That's quite important, right? This is important because there's a domino there and there's a domino here. They're different dominoes and they can't be the same pairs. And therefore this digit would be common to them both. That one can't be a 1, or you'd have the same pair across here as across there. We don't have to know whether this is 3 or 4 to know that that's true. This digit is a 1 now. That's got to apply around this corner as well. This digit can't be a 1, or that would be the same as that. So we found 1 here. Does that let me do the 2 and 3? I don't think it does. I don't know why it would. What about the 3 and 4? 9, 1. Look, we've got quite a few 1s in the grid. Actually, just think about the old hashtag, which is, okay, I'm going to colour these columns and rows differently. In each case, each of these rows and columns contains the digits 1 to 9. Now, for once, I'm not going to ask you to consider their sum. Blue was a terrible choice as we've already had a red. Okay, each of these coloured rows and columns contains the digits 1 to 9 once each. Now, every one of them is going to contain each of those digits, and therefore each of those digits looking across a border. There's going to be a pink 1, and an orange 1, and a light blue 1, and a dark blue 1. And they're all going to be looking horizontally across a border. This one looks across there, this one looks across there, this one looks across there. We haven't found the orange one yet, but it'll look across at pink. That's going to be 4 of our dominoes, 4 different dominoes that one is looking at. We're also going to be looking up and down through, look at that, we've got some of them here. Every one of these bands that I've highlighted is going to have a 1 creating a domino. That's going to be 8 ones and different digits they're looking at across the border. And that's going to be all the possibles. 1 can't look at itself across the border. That would break Sudoku rules. So there's going to be one instance of 1 looking at 2, 1 looking at 3, 1 looking at 4, 5, 6, 7, 8, and 9. All of those pairs are going to be represented. That's going to be the same for every Sudoku digit. 9 is going to be looking across a border 8 times. Now, look at these other cells. Oh, now I'm very confused. Right, I'm about to... These other cells that I didn't highlight do not look across borders. Okay, I'm now going to get rid of the other colouring. I just said... These cells that I've just highlighted do not look across borders, but shouldn't there only be one each of the digits 1 to 9 left over? And yet I've highlighted many more than 9 cells now. I've highlighted 25, I think. What's that discrepancy of 16? I know what it is, actually. I know what it is. Okay, that was really worrying. I think my brain was just saying, this doesn't work at all. But that's just because obviously I'd misunderstood. Right, there are, let me turn on the pen tool. There are 8 look acrosses. So what I'm going to do is use a color to look across. That is a look across by 1. That's another one. This is a third one. Now you may see what was troubling me. Well, there you can't guess what idiocy was going on in my head. But what I hadn't understood was that in these cells, let's just highlight these for a moment, there are border guards doing double duty, if you like. This border guard is looking across at that cell and also looking at that cell. And as we've seen, he's got to see different digits in both. So he is forming 2 of the relations that 1 has with the 8 other digits. And yet he's only using up 1 digit. So the discrepancy I was seeing between 9 and 25 is exactly equal to these double count cells, and there are 16 of them. Okay, well, that was just some philosophizing to explain an irrationality in my head. Now, I'm going to get rid of those lines. What I'm going to do instead is think about the digits that 1 sees. Let's colour them. There and these 2. You see, we've got quite a few of them out. That is 6 already of the digits that 1 sees across the border in this puzzle. There are only 8. We've got to find a 1 in row 3 looking south. And we've got to find a 1 in column 4 looking west. Well, that can't be here or here or here, here. Well, it can't, right. We've had those 2 1s. I can just put in a 1 there by ordinary Sudoku. It can't be there because it would appear here again. Now we get a 1 in one of those cells. It can't be here because that would be a 2. So we get a 1 there. There's a 1 in one of those 2. That could be the one looking across to row 4. Now we found the 1 looking across from column 4 into column 3. So now I've got 7 of the 8 pink cells highlighted, and these all have to be different. Right, that tells me that this digit cannot be a 3, because that would make this 2 because they're in the same box, and this 3, and we'd have 2 purple 3s. So that's a 4. This is 3. And now we are getting even more confidence, certainty on what digits 1 is seeing. We found a 4 and a 9. This digit, whatever it is, has appeared there and it's already been seen by 1. So it can't turn up in any more purple cells, including these 3. And in this box, that digit, whatever it is, I'm going to give it a letter now. Oh, I'm sorry. I'm just trying to keep a track on what I'm seeing. That digit A is in one of these 2 cells because it can't appear in purple because it's already been in purple. It can't appear there because it would appear here in purple. We could call that B. I don't know if I'm being stupid here. I probably am, but it's different. Because 1 is purple there and 1 is purple here. 1 is looking at them both. That's the reason. Now, 4 4 has appeared in purple as well. So that can't be in these cells either. So there's a 4 in this. This is a 4 and a pair. They are different according to this column. And now 3. Oh, well, that's really interesting. 3 is now going to appear in one of these purple cells. 3 is either there in this box. Remember, this is a 4A pair, which aren't 3. 3 sees them both in this column. So 3 is going to be in one of those cells or that one, and that's going to mean it appears somewhere here in purple, and it doesn't appear here in purple. That's got to be a 2. That's a 3. Now it's not this one that's a 3. 3 is either here or here in this box. It could be B, or it could be there. And now we've had 2, 4, 3 effectively in one of those, 9. Everything else is 5, 6, 7 or 8 in purple. We've still got one purple digit to find. The 1 is in this row, and his purpleness is in this row. So 1 can't be here or here or here. 1 in row 3, I don't like marking across boxes, but it's in one of those cells. So one of these is the last purple containing a 5, 6, 7 or 8. There's one there, there's one here, and one of these two is also... Oh, this can't be a 3 by Sudoku now. So that is the 3 in the box. And this is 5, 6, 7 or 8 in B. I mean, this is following this general principle as well, again, of that's using up both B's in this column, which is proof that B can't be 2, 1, 9 or 3. And we know from this box it can't be 4. Actually, these two must contain a 9 now. Well, we know where that goes. That must go here. Now I'm going to colour the cells next to 9 in the puzzle, because it's the next best. Oh, I don't know, maybe 3 is going better. We've found 3 3s on borders. Looking across at, yeah, 3s are better, I think. So 3s, I can't be colouring all the border views of everything, but I am going to colour the 3s one. I'm going to use yellow again. So those cells that I've just coloured yellow are all different, and 3 is looking at them all across the border. 9, 4, 1, 2, and this baby here. Now there's a 3 somewhere in this row looking north at a digit, not there, not there, at a digit in one of those cells. The trouble with this puzzle is how are we ever going to work out the differences between 5, 6, 7 and 8? They're just not going to, I mean, it's not going to come down to these white dots, is it? Oh, hang on. There's a 9 on one of those cells. That's just Sudoku. Right, I'm going to do one more colouring of digits that something is looking at. So greens are cells that 9 is looking at. There's another one. 1, 3, this one and this one. And that's just the 9s I've found so far. There has to be a 9 in this column. It can't be there. And it can't be there, because then it would be here and clash with that one. So 9 in this column is in one of those 2 cells. Now, is there a rule that it can't appear twice? No, on box borders. No, actually, I'm prepared to bet. I'm not prepared to bet, but I think there's a very good chance that these 16 cells, I was going to say it's going to be 2 of, I think there's a good chance it's not going to include any digit 3 times. I don't know. There we are, I've said it. I was going to say it's going to be 2 copies of each of 8 digits, but there are 9 different digits. That was nonsense. Right, what can we do next? We've done quite a lot, actually. We've done quite a lot. These are from 5, 6, 7, 8, just because they have to be. A is 5, 6 or 7, 8 as well. It's in one of these cells. A is now in one of these two cells. And it's therefore in one of these two, because if it's there, it's there. So A has to be in one of these two. It still feels like a game I don't know how to play at all. What about 9 in the central box? It can't be there. It's in one of these three. Nine, I didn't really work out whether 9 couldn't be there. 8 would be here, obviously. That 8 would then have to appear in one of those cells. I don't think that does anything particularly. Actually, what I should do is mark positions for 1. Rather than trying to count this 1 across boxes, I should mark all possible positions for 1 in the grid. Now, let's check my purples again, just in case something's happened. 9, 4, 3, 2. The others are 5, 6, 7, and 8. 3 of them are there. 1 is going to be somewhere here. Is there something obvious I can do at the moment? This is useless, but I've found A is in one of those two cells. B is another digit from 5, 6, 7, or 8. I'm going to call this one C and this one D, just to differentiate these digits from 5, 6, 7, 8. So that pair is B and C in some order. It might be a way we know the order based on not being able to look across, but I don't think there is yet. Now, what I was going to try and use that for is to sort of ponder where does C go in this column, and then maybe even, well, we've got A in one of those two, B here, C here. If D went there, this would be a 2, 9 pair. Actually, 2 can't go here. So 2 and 9 in this box are in this group of cells. And this must be from 5, 6, 7, 8. Now, does that make it A, or could it still be D? I don't know the answer. What I was going to be getting at was that these can't both be D, because they would both be touching this digit both times. And does that help, therefore? Does this digit have to be in one of those cells? I don't know. I don't know. I thought I might be getting something done, but it doesn't really feel like I was. There's not enough information. That is something I feel quite strongly at this stage. I think we've done good work, but my colouring system's awful as well. I keep looking at those two and going, are they really the same? They're definitely not the same. I'm using extra region colouring, so they are always different, the greens. 1, 3. None of them are 9 yet. I do need a green 9. No, I don't. Green is the digit that 9 is looking at across the border, so I definitely don't need a green 9. I need greens of everything else. I need a green 2 somewhere. Oh, sort of interesting. Is it? Because that green 2 is going to be on a border looking at a 9. See, neither of these could be a green 2, because those can't be 9. So green 2 is not in box 5. That's probably not really very interesting. It's not. Green 2 could never have been in this row because it would need its 9 to be in that row, and we've already had the 9 in that row. There is going to be a digit above a 9, a sort of digit bordering a 9 in this row. And there's going to be one in this column. And there's going to be one each in this row, 9 is in one of those cells. So the green digit is going to be in one of those two, just above it. Nine in row 4, I don't know. Maybe it's here. Now, I've finished all my long arrows. They're just totally done. I've done every digit on them. This cell, I mean, okay, this is not 1, 2, 3, or 9. So it's 4, 5, 6, 7, or 8. It could be 4. But otherwise, it's A, B, C, or D. But it's C's, A and C. So this is 4, B, or D. Now, can we find that any of those have sat opposite a 2 across a wall? Probably not. That's the sort of thing we're going to have to look for, though, is creations of border disputes. Right, that is 5, 6, 7, or 8, because that is. I don't know whether these are both A. They could be. What would happen if these were all 4 A's? If we got any Sudoku going on, we know there's an A down there somewhere. There'd be an A in one of those two cells and one of those two. I feel like there's some rule I just don't get. B, B. One of these is B. So these include 9 and B. Oh, this can't be, no, I don't know what this is. I don't want to label it as a letter. Oh, mind you, if it's either 4 or D, how about that? Look, we've got A, C, and B looking up this column at this. This can't be 1, 2, or 3 because, or 9 because it sees those somewhere in the columns below. So this is either D or 4. I am going to label it as those things. And it's there as well. And the reason I'm bothering to do that is because that digit has to appear in row 3, and it's definitely in one of these cells. That feels like it might help somehow. D or 4 is sitting in one of these two cells. If it was there, that would push 1 here. Well, has one has seen 4 across a barrier? Has it seen D? It's seen B, and it's seen A. One is yet to see C, D, and only those across barriers. One has seen 2, 3, 4, and 9. Oh, A, C, B. So it's only got D to C. And the 1 is in one of these cells. So one of these 3 is D. That is the point. That is what I should have been doing. And that means D in the central box is either here or here. One of those two is D in the central box, because it can't be one of these purples is D. One of these possible purples is D. Now, can that be D? That would definitely make both of those D, both of these 4. That's weird. So this is BC. D is here, A is here. This digit is 2 or 9. That's all that's left. Have I missed one? No. A, B, C, D are the 5, 6, 7, 8 set. 1, 3, 4. This is 2 or 9. And the other one of 2 or 9 is in one of these cells. Now, is there anything impossible? If that was 2, one of these would be 2. What has 2 seen so far? It's seen 3, 1, this B or C jobby, something here. It hasn't seen much. This could be a 2 easily. But it could also be a 9. Okay, if that's a 9, we've got 9 here. That's going to have to be a 9. 9 is going to see 4 or D there. 9, I'm trying to colour in green what it sees. There's a 9 in one of those cells. I feel like there's probably a 9 in row 6, column 1 or 2, but oh, I don't quite know. Just totally stuck. Right, let's think again about A, because I'd love to know whether this was A or D. It would make quite a big difference. A is there and there. So A is seeing 1 and that. A down here is not seeing anything. A here if this is A, it's seeing D here. Because, that might be wrong. Yeah, no, that is right, because this has to be D. This is A or D, isn't it? This can't be 2 or 9. It is A or D. So if that's A, this has to be D. Then we've got a 2-9 pair here. Then actually we've got a 2-9 pair here as well. Oh, that might help. Don't know how. I don't know how. Okay, but what I was talking about was A. A is seeing that cell and that cell. It's either seeing that cell and that cell. There we go. This cannot be A. No, it can very much be A. Sorry, I'm suddenly getting hung up on it seeing 1 there, and this can't be a 1, so that can't be A. It is very much the 1 that has to be avoided. This is why this is so blooming difficult. Where's A in this column? This is quite an interesting question. I've got the answer as well. That's really odd. Okay, A in this column can't be in those 2 cells because that's a pair of A's. That's where we started with A. So it's not in those 2 cells. It's obviously not 2, 1 or 9, and it's not in this B cell. Now, it can't be here. I haven't got the answer, but I'm close to the answer. A can't be here because that would force this to be A. And then these 2 look across the borders would be the same. So that's not A. So A is in one of these 2 cells here. I thought it was going to be that one. No. Maybe. If that's A, this is D. Because that cell is actually A or D, I should have labelled this one as A or D. That's what this is, A or D here. If that's A, this is D. Yeah, maybe that's not impossible. I have limited A to one of those two cells in column 3. A in column 4 is in one of those two. A cannot be here, because since that couldn't be A, this couldn't be A, and in column 4 A would be here. A would now be in both of these cells, and the look across to that cell would be the same from both. So that's not A. This must be A. That has taken ages. But still, it's true. This is A. Now I've got 4 of these A's. I'm going to look at what A is looking at across its borders, because I've got 5 of them. It's looking at 1, something that is 1 digit away from A there. This is not A anymore. We know it's not A. And now we've found D. This is definitely D and is not 2 or 9, because D is not 2 or 9, I believe. Yeah, that's correct. So this is now definitely 2 or 9 in red here. That is a 2-9 pair. D is 5, 6, 7 or 8 in the center of the grid. Now, has that taught me that these are Ds? I don't think it's told me what they are. But we've got A's, we've got B's in these columns. We've got 1 from 2 or 9, so only one of these is from 2 or 9. Has 2 looked across at 9 yet across the border? Not yet. So these 5 reds are all different. None of... That one is 2 or 9, and none of the others are 2 or 9. Not many of them can be 3. Where are we going to put 3 in this column? Could be here. Otherwise, it's here. On the white dot. I don't know. This is confusing me thoroughly. C is looking at a 1 and a 3 here. We need a C still in this column, in one of these 3 cells. Yeah, I don't know quite what the expectation is there. This was D and this was D. One of these 3 is D, and it could obviously be the circle digit. But I think also one of these 3 is 4. These digits do include 4 and D. Well, and they include whichever of 2 or 9 that is. I was going to say, therefore, this is a group of 5, 6, 7, 8. But D is from 5, 6, 7, 8, so that's not accurate. This digit is going to be in this group. Yeah, I don't know. So, A's red cells. We've got 5 of them found so far. Where's... Oh yeah, we've done A in column 6 and 7, A in column 3 and 4. A in row 4 we've done by default. A in this row is in one of those 2 cells, I've just noticed. So there's another red in one of these 2. Beneath them. A is there, so in this row it's in one of these 2. And therefore its counterpart digit is down here, another red in one of those 2. And A in row, whatever this is, well, I don't know where it is. It could be there or it could be here. quite excited that I've discovered that 2 of the arrows were identical and were both A's. I mean, I know it's not rocket science, it's not a thrilling discovery, but it's quite interesting for this puzzle. Do I ask where's 3 in red and get excited because I can identify that it's not in those cells, or that one, or this one, or that one? Start narrowing down. Well, it's certainly not in row 4 anywhere as a red cell. And that's 1, 2, 3, 4, 5 of them accounted for. So I've accounted for so the red cells are opposite A. No, I'm looking for 3 in red, and they are opposite A. That's what I'm looking for. 3 in red. Well, it's not in row 7, 6, or 3. It could be in row 4, 3 in red. It would have to be in one of those cells if that was the case. Alternatively, it's not this one because of the white dot, and it's not there or there. The red cell in column 3 is in, possible red 3s in column 3 don't include that because of this. So the red 3 seems to have to be in one of these 3 cells in the puzzle. So 3 is a bit limited, a little bit limited in box 4, in a very surprising manner. And wherever it is, it's sitting across the field from A, across the border from A. These can't be a 3. No, that's not true. If that's a 3, one of them is a 3. Yeah, that is not true. Not the red 3, but it could be a different 3 apart from the red 3. This is so complicated. This is a pair of digits on a white dot. That one can't be 1, 2, or 3. So these are, I suppose this one could be a 3. But they are from 4, 5, 6, 7, 8. That much is clear. I mean, that's quite a wide spread, I know. I was starting to get excited about where's the 2 in this column. But I think I've got that cell available. There is a 2 in one of these 3. It could be there. And that would be opposite B or C, whereas this 2 would be opposite the other one of B or C. So 2 could be here. Otherwise, it can't be here because that can't be 1 or 3. So otherwise, it's here. The 2 in this column is in one of those 2 cells. Can we have 2 opposite a 9? Or have we had that yet somewhere? I haven't seen it. I don't think we've had 2 opposite a 9. Even despite the fact that we've got a 2-9 pair there. Oh, this is so hard to keep a track of. 2 could be in one of these 2 cells. How on earth do you make progress? Is there some way of seeing this puzzle that's really sort of intuitive and straightforward? It just feels to me like there can't be. I mean, the work I had to do to even isolate 3 read 3 to one of those cells. And it might not have been right. It might have been a stretch somehow. D, D, D. Can that be D? Maybe I could rule D. No, there's no way. There's no way I can rule anything about D. I'm just going to have to spot something really big and useful, or probably something really small, but it turns out to be very useful once you get the idea. I'd give a lot to know whether this was 4 or D. Whichever it is, it then has to appear in one of these cells. And what good is that? Here in this row, oh no, I thought I'd said 3 was in one of those. 1, 4, 2, 9. These are from 3, 5, 6, 7, 8. Now I'm getting into desperation pencil marking territory. There must be something about the arrangement of how every digit looks at a different cell. Like, all the connections must exist in this puzzle. 1 clicking with 2, it's 1 clicking with 3, 1 clicking with 4, 2 clicking with 3, 2 clicking with 4, etc., all the way up to 8 clicking with 9. And by clicking, I'm talking about being across a border. And something about that is going to be subject to a useful question. But I do not know what it is, and I don't think I'm even approaching knowing what it is. I don't know. It's so strange. 2 and 9 are going to pick up partners up here that can't be 1 or 3. Only one of them could be 4 or D. I don't know. 2 has already seen whatever this is out of B or C. 4 has seen 3, so the 4 that appears here is not looking at a 3 beside it, here, here, or here, here. Well, in fact, those 2 potential 4s can't have a 3 on their left. This one, as a potential 4, can't have a 3 on its right. Where is 4 going to mingle with? Oh no, we've already had 4 mingling, as I'm putting it now, with 3. That is my problem. Okay, the yellow cells, they're the ones that 3 sees. 9, 4, 1, 2, and C so far. What else should 3 see? 9, 4, 1, 2, and 3. The 3 here, it could be there looking at A, or it could be here looking at A. I just don't know. Goodness gracious, I don't get this. 2, 3, 1, 9. It's a really strange file. I didn't know this was going to be this difficult. I honestly didn't. 46 minutes and I'm nowhere near getting towards a finish. It just feels like there are nowhere near enough clues. 9A. 9 across the border from A could happen in either of these cells. Can it be ruled out of everywhere else? No, it could be here. Well, that's quite interesting. So if this was a 9, then the 9 here would not be allowed to be opposite the A. If that was a 9, the 9 here wouldn't be red, and the A wouldn't be green, I don't think. Don't know that. Okay, let's consider this column again. We've had A, B, C, 1, 3. 4 and D and 2 and 9 are confined to these cells. 9 is either here or here. Is 9 opposite the other of 4 or D? I'm not sure. I think I'm going to have to go for a bit now. Sorry, I'll be back with you in a while. Right, I'm sorry about that. Let's resume. Well, say resume. I don't know what to do. We were looking at red. There have to be 8 reds. And we've found 1, 2, 3, 4, 5. Reds are the things playing opposite A's. We found 7. Well, we found 5 of them. Possible locations for 2 more. The other one is going to be opposite A in this row, and therefore it's going to be in one of these cells. It's very hard to know which one. But that one is not going to be 1, 2, or 3. And we've limited 3s in reds. That's probably how we knew 3 was in one of these cells. What about 2s? Because the one in this row can't be a 2, nor can this one, nor can this one because of that 2-9 pair, nor can either of these two. This one can't be 2 on the white dot. This is the 2 in red. Well, it's a good thing I had a break. That's a 9. Now, this is not 9. 4 or D is not 9 because D is 5 to 8. That is 9 in column 4. This is now a 4 and D pair. It's got to be. Oh, that's not doing what I wanted. 4 and D. That is a 4D pair. Let's take the corner marks out. So this is 9, 4 and D. That is 1 and 3. 2 is in one of these cells. If I could say it's not here if I've had 2 touching 9 across a border. I haven't had that. What are across the borders from 9s? Greens. Have we done any ruling out of 2s from greens? Or ruling in? No, ruling out is better again. No, we haven't. I'm just going to write a 2 into those cells. Now, 4 and D. What's going on with them? Where do they go in this column? There must be something happening here. I feel like that one cannot go there. Why do I feel that? Oh, look at 9 actually. Hang on. 9 is in one of these 2 cells. If it's there, this is definitely an 8, and that would feel like a moment. It would stop 8 being A or B. I mean, that would be very interesting. But 9 might not be. 9 is almost certainly going to get forced to be here. Well, I say almost certainly just because it seems the least helpful option from this point, and I don't really know what to do. Now, okay, let's go back to reds, because we've now found 1, 2, we've limited 3. 9 is down. Is that 9 in red down there? No, that's... Let's think about where 9 is in red. It could be in this row. Or I think one of these 2. What were we putting them there for? They were opposite A. No, we put red there because it's opposite A in one of those cells. That's why. I don't see... Well, hang on. If red 9 was here, opposite A, does that mean A would be green? No, A would not be green. I don't know. I don't know what that means. What I was trying to analyse was where this digit goes in column 3. It's 4 or D. And it's been opposite 2 already. And this digit. I feel like it can't go here. Oh, 4 opposite D, maybe we haven't done that before. Okay, maybe that's a good question. Where does 4 go opposite D? It's not a good question because it could go in any of these places and be 4 opposite D. So I don't think I can say, well, that cell in this column, it is either there or there. Maybe that's the point. I have to put both 4 and D in red. Well, I mean, that's not uninteresting. This 4 and D pair sees all of these cells. So it's not this 4 and D pair. This 4 and D instance, this instance of 4 and D, can't be in those places. So it's either in the missing red, or it's in one of those two, or it's down here. This is red being opposite A. That's useless. I don't know what I'm doing. I don't know what I'm thinking. Okay, in this column we've had A, B, 2, 1, 9. We've still got 4 and D. And we're saying one of them is there, one of them is in one of those two cells. And we've got C and 3. Can this be 3? Wow, I don't see why not. I don't understand why not if it can't be 3. It would be great if that couldn't be 3, because then that would be 3. These, in fact, these 4 cells are 3, 4, C and D. Are they? That's all they can be. Yeah, that is all they can be. This one can't be D, because D's in that cell. Okay, this is 3, 4, or C. These, that is 4C or D. And this is 3, 4C or D. I mean, I don't feel like I've got the power to rule any of them out yet. But this might be an interesting way of approaching it. Now, red. We've had red 1, 2. This can't be 4 or D. There we go. This cannot be 4 or D, because that would be the other one of 4 or D, which would also be there, and this would be the same as that. So this is definitely C. This is now obviously not C and is 3 or 4. This is also not C, but could be 3. So we found C, and we've got, shouldn't do it that big, should I? Sorry, I should just get rid of the the other cells. That is C, just like this is C. Maybe I should do it in the same way as that. I'm sorry, I can't decide on my numberage. Right, that is C. This is C. C here sees 1 and 3. C here sees these two things. A. So C has seen 1, 3 and A, and now it's seeing 4 or D. Oh, I don't know. I'm so confused by this puzzle. These are 2, B and C. I mean, that is worth noting. Those are 2, B, C. That's D. This is 4 and A. I mean, it's not any new news. It is. Well, this one can't be C. We've just said there's a C in its row. So that is 2 or B. Have we not had B opposite 9 or 2 opposite 9? Yeah, we've had B opposite 9. That's a 2. This is so difficult to pick out these things. Oh, lordy. Right, that's a 2. Now, were we marking what 2 was opposite? No, I don't think I've done that. Am I going to come up with a new colour? Yes. Yes, I am. What is 2 opposite? It's opposite 9 there. A. That 4 or D. 3, 1. This B or C. This digit is also opposite 2. Oh, there are 3 2s in these clusters. That makes me worry that I've done something wrong, but I mean, there's no evidence for that. So don't worry, Mark. Right, now, of the 8 blues, light blues, I've found 7 of them already. I've got them here. Whoa, this is getting interesting. They're opposite 2, so there's not going to be a 2. So we've had 1, 3, 9, A, B or C, 4 or D. So the other 2 we've got are the other one of B or C and the other one of 4 or D. Now this one, who knows? B, C, 4 or D. And where's the extra one? The extra 2. So I haven't put a 2 in this column yet. Well, it's not there and it's not here. I tell you what, it's not on the white dot if that is 4, B, C or D. That is suddenly worth pencil marking. B, C and D are from 5, 6, 7, 8, so that's not 2. 2 can't be here. 2 is either here or here in green. Have we had a 2, 9 before? Yes, we certainly have. So 2 is here. In the column. It is. It bloomin' is. It's not there, but on the white dot. I'm just going through this one more time. It's not there or there by Sudoku. It's not here because of the white dot to 4, B, C or D. And it's not here because we've had a 2, 9 before. So it is here. 2 is opposite B or C there. That's the final light blue cell. That's a BC pair. This is therefore not B or C. This is now 4 or D, the same as that. No, different from that digit because they're both the same colour. So these 3 are the same digits. But I don't know if they're 4 or D. And I don't know what D is. Right, I'm going to get rid of the blue colouring because it's sort of done its job. I know where A, B and C are. I'm going to leave 2 cells coloured in blue that have to be oh, that's dangerous. They have to be different from each other. I'd rather colour these the same because they have to be the same as that one. But then I'm doing different thing in one colour from the other. But I'm only doing it because of 4 and D and this weird situation where one of them is in one of those cells. I think I'm actually talking myself into doing it. For light blue only, I'm recording the same digit throughout the puzzle. Now, then it's going to be in one of those 2 cells. No, okay, it is crazy. I've talked myself out of it again. That 4 and D are different from each other. Now let's look at one of the other colours, yellow. 1, 2, 4, and 9. Yellow is what's opposite 3. I think. Yeah, I'm just checking that that's right. Right, 1, 2, 4, and 9. Now, opposite 3 into column 4 is one of those 2 cells. Opposite 3 into this column. Where's 3? It's not there. Ah, it's not there. 3 is in one of these cells. But we've had 3 opposite 9 up here. So 3 has to be here. Well, that's great news. That's great news. That is 3 because now this is 4 and not D. And now this is D. And luckily I can still remember what was going on. I can't remember how I do the colouring. Right, I take 4 out of there. That is D. Actually, I should do it like that. These ones are definite 4s now. And that's really interesting. Now I can start colouring what's opposite 4 with some degree of excitement and certainty. Hang on a second though. D. This is D. Let's look at the Ds I've got. I've got these Ds in the grid. I mean, and now I can pick almost any letter and get quite excited about what I'm doing with it. Right, look at this. No, this is not a letter, I know. This sees A and B. All we've got left in this column is 5, 6, 7, 8. So it is A, B, C, D. This one sees A and B. So this is C or D. This one is not A. All I know is if it's B or C, that is a BC crossover. This one is also not A, but it's consecutive with A. Okay, I was going to look at what's opposite 4 and give it a completely new... I can get rid of those blues, by the way. They're done. So I can use a new colour. I can use orange for what's opposite 4. Now, I don't know what letter that is. That's obviously a 2. Up here, it's those 2. Here and here, we're opposite 4. They're also opposite 9, which is why they're coloured. So we've had 3 being opposite 4, so that digit can't be 3 or 4. That must now be D. I spent some time trying to prove they weren't going to both be the same. It turns out they bloomin' are. Right, that's a D. So in orange, we've got D, 9, 3, 1, 2. This now can't be D, and it also can't be A. So this is B or C. And we have now got the BC bridge border dispute going on. So we can't have another BC one. And in orange, I've got 1, 2, 3, 9. Orange is looking at 4, so I'm never going to get 4. So now I have to have A, B, C, and D. I've had D. That's B or C. I need an A in orange opposite a 4. I've still got to have a 4 in this row with an A, B, or C beneath. I don't know where it's going to go. And I've got to have a 4 in... I've had the 4 in all the columns. I've got to have a 4 in this row. Well, that's not going to have an A beneath it because A was there. So the 4 that's touching an A is in this row with an A beneath it. That's very hard to know. One of these dominoes is 4A. But that means that the 4 in this row is going to have B or C beneath it. And it's going to have the opposite of this one. It's going to have this digit beneath it. I don't know what to do with that. Oh, I do know the 4 in this row is in one of those cells. So the B or C that we're talking about is in one of these 2 cells. So I've got a virtual BC pair. Do I know that 3 is in one of those cells? No, I don't. That is just a possibility. I've got no way of marking that the 4 is above a B or a C here. But that B or C is also here. Whoa, hang on. No, it's not. That B or C is also here, because obviously these 2 are the same. Yeah. That B or C is also here, and then it's going to be in one of these cells. So these are 1 and B or C, apparently. Well, I'm going to mark that, because that's quite interesting. Right, well, 4s were good, but they created a new colour, and it's keeping track of these colours is the hardest part of this puzzle. What is opposite 2s? Because why haven't I marked them? I'm going to be creating yet another colour. Okay, we're going to go with the blue this time. Let's go with dark blue. So playing opposite 2s. Oh no, I did this. We used light blue, and that's how I got them. I've done 2s. Sorry. Oh, I do. Yeah, I was going to say, how do I not know whether this is 3 or 4? I do. That's 3. These can't be 3. Now I do know there is a 3 in one of these cells. These are 3 and B or C. And I am going to mark them as such. Because that is a 3BC triple. And these are A, D. I was going to say E, but there's no E. They're A, D, 4 and 9. The D has to be in one of these cells because we've got a D there. So this is an AD pair. And this is a 4-9 pair. And I defy you to tell me I'm wrong. Actually, look at how the rest of the row was marked. That's always a 4-9 pair. Fine. Good. Very good. Right. Now. Greens. Shall we look at greens? Greens are what are opposite 9. So we've got a new green here. We've got new greens everywhere. Got a green there. Right, greens are what are opposite 9s. So either A or D here, but let's go with the ones we've got. 4, 2, 3, 1 in green. B and either C or D. So that's either A or D, and there's one more green to find. I think it's in this row, isn't it? And it's under a 9, which is not in one of those cells. There's a 9 in one of these cells with a green underneath it that is A or D. Well, was not quite as helpful. Let's go back to oranges. 1, 2, 3, 9. And oranges are recording what's opposite 4. So then I need A, B, C, and D. I've got D, B or C. Now I've got 2 more oranges to find. These are what are opposite 4. There's a 4 in this row that is now not here. It's over here. This is a 4-9 pair. And the orange is in one of these cells, along with the green, and is something from A, B, C, or D. We've had D, so the orange here is not D. Annoyingly, the green could be, I think. Ah, we've had green C or D there. That, I was going to say that digit has to be in this column and it must be orange here. No, it could have been there. This is a very, very crazy puzzle to get your head around. Those I'm just remarking as for a centrally. How can I not know what that is? It's B, C, or D. I mean, that's useless, isn't it? D there. Oh, you see, I wish I knew this was 9. We've got a 9. How do these ever get disambiguated between the columns? I mean, is that white dot the only thing that's going to disambiguate these two columns entirely? I think it is. But what's ever going to disambiguate these two columns? That 1 that we got. Oh, no, maybe there are more 1s to go. So, I don't know. I might be. No, I think this is actually very important. I've definitely got more work to do identifying stuff. So in this row, there's an A here, there's a C and D there, 2, 3, 9, and a 4 over this side. 1, I still haven't identified which of these cells 1 is in. And there's a B somewhere. I haven't really thought about B much. Maybe identifying B and C would be a great way to go. One of them's next to 2 here. One of them is next to the other of B and C. No, both of them are next to 2 in these cells. Both of them are next to each other, of course, across this divide. And one of them is next to 4. Then here, B is opposite 9 and 1. C is opposite 1 and 3. Where else are B and C? One of them is here. Oh, I'm not doing it the right way now. Now I'm confusing myself. Right, let's have a look at A's in the grid. We've got an A somewhere out here. And somewhere here. Now, this is slightly interesting. If A was in one of those cells, it would be under D, because it couldn't be under itself. Have we had an AD pair somewhere already? We could have done there. We've had an AC. Oh, that is a bit interesting. Oh, so this can't be AC. So that digit is B or D. You see, that is interesting. I know this is a chocolate teapot triple, useless because we can't identify any of them. But we're sort of closing in a bit, I feel. Aren't we? Maybe we're not. But we've had AC. That was valuable. We've had A3. I could have just done that by going, that's red and it's C, so this is red and it's not C. I mean, I could have done it that way. I should have done it that way. This red is a letter that is not C. It's obviously not A because the red is measuring what's opposite A. This red is B or D as well. Like that one, but different. One of these two is definitely D by Sudoku or something. Is it red or is it pink? What have we had in pink? We've had A, 9, 4, 3, 2, B, C. We've had A, B, C, 2, 3, 4, 9. This is opposite 1. So the remaining pink in this row is D. Well, it's not sitting here. A, B, C. Yep, this is not pink. Pink is here along with red. Definitely one of those is red. So we need D in pink, but we also need D in red. Right. I think, how many pinks have we had? 1, 2, 3, 4, 5, 6, 7. This is the 8th pink and is the D. The D here is pink. The other digit here is therefore red and is not D. And therefore we need a red D. And I want to say it's here. Because isn't this the red 9? There is meant to be a red 9. How many reds have I coloured? 1, 2, 3, 4, 5. Ah, I see, no. Maybe the red 9 is here and the red D. Oh, hang on, what? The last red, which is opposite A, is in this row. That can't be red D. Well, I'm nearly getting this. We've had 1, 2, 3 in red and C. I'm talking prematurely about the last red, am I? 1, 2, 3, 4, 5, 6, 7. No, I've got 7 of them highlighted. The last red is somewhere in this row, sitting above A. I think I'm getting there now, but I haven't quite figured it out. D is not red here. That is the key thing to cling on to, because D is pink here. So the red digit, which can't be 3, is B or C. And it can't be C, because we've had B. So the red digit is B. And that means B's not over here. This is 3 and C. The red digit there is B. So the red digit here is D. There we go. Now we've had B, C and D in red, as well as 1, 2, 3. Red is measuring A's. The remaining red, 9 and 4 still to go. So the 9 is here, the 4 is one of these cells. One of these is red, and therefore the 4 is above an A in one of these two cells. That A, do we know its colour? I almost don't even want to get involved in that. Finding that that was D makes this C, and that makes this B, and that makes this C, and that makes this B. And now in orange we can say we've had 1, 2, 3, 9. Orange is measuring what's opposite is 4. We've also had B, D. In orange we're going to need C and A. And they're going to come, where are they going to be? Oh, that's weird. It looks like I've had them in every relative row and column. I can't have. What am I talking about? I'm trying to talk about where 4s are. I know, yes, I looked at oranges. I should look at 4s. I've got a 4 in one of those cells. So one of these is orange. It's the C. So we've had 1, 2, 3, 9. We need all of A, B, C, and D. We've had D and B. Here there's going to be an orange C. I'll try and remember that as vitamin C, which you get in orange. And here there's going to be an orange A, sitting under a 4. So if the A is orange here, the green is not A. What have we had in green? We've had 1, 2, 3, 4. Green is measuring what's opposite 9, so we only need the letters. And it's not A, and we've had B and C. The green here is D. And therefore the green here is A. Vitamin A you get from eating greens a bit. So in this box at least, the C is orange and the A is red. What's the D? I don't know what the D is. Does that matter? Goodness, it's so confusing. Right, D is next to A in number because of this white dot now. A and D are consecutive. That's what I'm trying to say. Oh, wow. So D is consecutive to A, but it's also consecutive to this digit. Now that can't be A. So A, D, and this, oh, if I could say this wasn't B, my goodness, I've done something then. Then I would know this was, I feel like I'd know it was a 9, I would. How do I know this isn't B? These can't have a B in, because B is in one of those. One of these is B. How can I stop myself from believing this is B? That would be C. You'd have B. There'll be some colour that B has not really appeared in. B has appeared in pink and green and orange and red somewhere. There, I think it's in red. So it's yellow. So I need to do something with yellow now. Yellow is what's opposite 3, and I've had 1, 2, 4, 9 and C. Opposite 3, oh look, there's D. I hadn't marked that yet. C and D, that's good. This one is opposite 3, that's A. I've had A, D and C. The remaining yellow is a B opposite a 3, which is in this row in one of those cells. The remaining yellow B is in one of these two. So these are 4 and B. I was going to say by Sudoku, it's by anything but Sudoku, but that's going to put a 1 here by Sudoku, which is going to make sure that this pair is a 1A pair, which I could... No, I couldn't have figured that out before. I'm figuring it out now. And in this row, we've found everything. 1A, C, D, 2, 3, 9, 4B. Now, B being in one of those, unfortunately, did not make any impact on B not being there. This digit that is consecutive to D and is not A or C, given that D is 5, 6, 7, or 8, this is either 9 or B. Oh, now I'm going to have to figure out. So, what the relationships are here. Oh, goodness gracious, this is doing my head in so badly. 1 is opposite pinks, and 1 has been opposite A, B, and C. So 1 is opposite D. So one of these columns reads 1DC something A. Now, it was vitamin A was green here, so the A here is orange. And orange is the thing opposite 4. So we're reading down 1DC4A down one of these columns, 1DC4A. So the other column is reading AB19D, and that can't be in this column because it would break this cell. So it's this column that goes AB19D. I mean, that has blown my mind. I hope it's right. Oh, I'm trying to do this. Wrong. AD19. No, it was AB19D. I was right. AB19D. And then up this column, I can take out those letters and numbers. I'm so confused. And in this column, we can have 1DC4A, and that can be 9 or B. I don't know which it is yet, but at least I've identified what these are. And I can colour these now, somehow, because we'd had... This was green A, wasn't it, for the rabbits eating the vitamins. So this is orange A, and this is green D. Now we've had green D, B, C. We've got a green A here. That's right, yeah. Now, A is the digit that's under 4. That's fine. And D is under 9. Yeah, okay. Red here. What were we doing in red? We've had 1, 2, 3. Red is opposite A. C. So that is red because it's opposite A. So is this one. They're obviously red, right? These ones are not red. Right, good. And now in pink, which is opposite 1, I think, we've had 2, 3, 4, 9, A, B, C, D. Okay, that's good. Okay, I'm getting rid of pink now. It's done the job. In green, yeah, I'm going to label one of these green. In green, we've had 1, 2, 3, 4. Green is what's opposite 9. So then we need A, B, C, D. We've had D, B, C. Oh no, the green one here is A. I knew that, and that doesn't help me label which one it is. This 1 is going to help somehow with that, is it? I don't know. This is a 1. I can write in 1s. They're proper digits. I can write in 9 and 4 there as well. Okay, what colours? Yellow. A, C, D. We need a yellow B. Sitting above a 3. Is it above a 3? It's above this 3. We need a yellow B. So coming down one of these columns, we've got B3. I'm sorry, I'm no better at this puzzle than I am. In this box, we've had A, D, B, 1, 4, 9. We've got 2, 3, and C still to place. What about this? What about this white dot? That's probably going to cure a lot of ills. Okay, in this row, we've had A, C, D, 1, 3, 2, 4. These are 9 and B, I now know. One of them's on the white dot. What's it with? What are these? In this row, oh, I don't know whether that's 4 or A, but we've had 9, B, D, 3, 1. As well as A and 4, we've got 2 and A and C to come. A, 4, 2 and C. So this is A, C, 2 or 4. I mean, if there's a way of limiting that better, I wish I knew what it was, but I don't know. Does that go with the white dot? Does it make it a B? The trouble is A or C could be 8. Oh, 9 is looking at that cell. So this is 9. There we go. D is 8. Oh, that's huge. Right. D is 8. Let's put in as many D's as I can dare to. Bear to. 8. 8. Look at those. They just go in. A is 7 because it touches D on the white dot. Oh, the trouble is I'm losing the A's, so I have to make sure I get all of them at once. I mean, I can't see them in the grid anymore, so that is 7 and 8 being A and D, isn't it? Yes. Right, what else is on the white dot? Because I have to be able to, here, this is it here, isn't it? 9 or B, which is 6 or 5. Connecting to 2, 4, A, which is 7, or C. Well, D was 8. C is not 8. This can't be a 9. This has to be a B. I don't know what it's connecting to, because B is 6 or 5. So it's connecting to C, which is 6 or 5, or 7 or 4. I don't know. Never mind about that for now. Let's put in a 9 here. Now, is that the digit we needed in red? Red is what's connecting with A, which has become 7. And in red, we've had 1, 2, 3, 4, 8. B, C, which are 5 and 6 in some order, and 9. So that's a 7 above it. That's the A. That's 8. Right, 8 is not green because we've had 8 in green. So 7 is green, which is connecting with the 9s. Right, we've had 8, 7, 1, 2, 3, 4 in green. These are 5 and 6. Of course, they're B and C. Okay, all the B and C cells, I'm taking out 7 and 8 as options. I'm regularizing what I'm doing here. So I've got to take this slowly because otherwise I'm just going to mess it up so bad. I don't want to mess it up at this stage. It's been so hard. Look, I can do 4 and 9 here by Sudoku. That 4 then goes here. This digit becomes B. Now, in yellow, we've had 4. So that's not yellow, that is. And yellow is measuring what is next to 3. So that 4, no, that yellow has to be next to 3. So that digit is 3. This one is C. That 3 we get to place up here. Take out of those cells. In this column we've had 1, 3, 4, C, 9, 8, B. C and B are 5 and 6, so we've got 2 and 7 left to go. They're a pair. B is 5 or 6, connecting with 7, therefore. And now B is 6. Ah, this is beautiful. This is beautiful. Right, I'm going to put in a 5-6 pair there and a 2-5 pair here. C is 5, B is 6. Repeat after me. C is 5, B is 6. C is 5, B is 6. There we go. That's a 2. That's an 8. 4 and 7 there. We've got 3 and 4 in this row. 2 and 5 here. This is just Sudoku, which I love. At this stage, it really... Oh, and that's 3 in the corner. That's 3 in the spot. Light. Sorry if I ever missed a C in the corner, which I might well have done, or a D or a B. Anyway, these 9 and 6, let's just get the digits right. 1, these are opposite 7, so that one's the red one. And that one isn't, because we've had a red 6. That's good. And here, in orange, we've had 1, 3, 2, 6, 7, 8, 9. Orange is what's opposite 4. And the 5 is the last one, not that one. So, in orange, we've had all the necessary digits, which we've just checked. In red, we've just checked them. We've had them all. In green, which is what is opposite 9 in the grid, we've had 1, 2, 3, 4, 5, 6, 7, 8. Lovely. And in yellow, which I think was opposite 3 in the grid, we've had 1, 2, 4, 5, 6, 7, 8, 9. It's all correct. This must be the solution. Don't tell me I'm wrong now, Staxis. Yes. Whoa, that's monstrous. What a puzzle. I mean, that is the sort of puzzle that I am terrified that other people with slightly different mindset just rattle through it. Not really a problem. I was always just looking for what was a bordering 8. It was easy enough. If you were like that, do say so in the comments. Brag a bit. And if it just took you 25 minutes, let me know, because I'm fascinated. I've found that absolutely frightening. I'm thrilled to have finished, and I'm, as always, thrilled to bring you brilliant puzzles on this channel every day in Variant Sudoku. It's such a pleasure. I'll see you tomorrow, I hope. Thank you for watching, and bye for now.